All right, in this scenario, I've actually given you degrees. So those handy formulas, that's funny. Let me get out of that. Those handy formulas we just came up with, we can't actually use. We need to use our fractions of the circle with degrees. So area of the sector, I want this area. So my area is going to be the fraction of the total area. So my fraction is 100 over 360 times total area is going to be pi r squared. When I put this into my calculator, I don't want that pi to calculate, so I'm actually curious what your calculator is going to do with it. Let's see. So we do 100 divided by 360 times pi times 14 squared. Let's see what it says. Oh, lovely. So your calculator leaves the pi in there, which is the answer I want to see. I like nice exact answers. So 490 over 9 pi, and we weren't given any units, so we don't need to put units down here. The length of the arc, I'm going to need to do the same thing. So my arc length is going to be fraction of the whole circumference. So I'm going to do the same thing, 100 over 360 times pi times 2r. So let's get rid of that, times 2. And we get 70 pi over 9. Notice I'm not doing any further calculations. That is enough. So I'm going to leave you to do that. Over here, though, I'm going to look at this one. So my arc length is 65.44. I know that my arc length is either going to be theta r, if theta is measured in radians, but I can see that theta is in degrees. So instead, my arc is going to be theta over 360 times 2 pi r. So I'm going to fill in what I know. 65.44 is equal to theta over 360 times 2 pi 25. And again, you would be tempted to start doing a bunch of algebra, but you got this big calculator, use it. I'm going to solve for 65.44 equals, instead of theta, I'll use x over 360 times 2 times pi, oops, 2 times pi times 25. And of course, we're solving for x. I don't know why this x is capital like that. Oh no, what is going on? Yeah, gross. Oh, goodness. Equals x over 360 times 2 times pi time. My computer does not like uploading videos and recording videos at the same time, obviously. Times 25, solving for x. So it gives us an exact answer. This one, since we started in decimals, we want to approximate. So Control, Enter, and we get about 149.98 if I round to the nearest tenth, which is what I want to do for degrees. So theta is approximately 149.98 degrees. Okay. So this one is another one that is wanting you to calculate missing bits, but this time we're going to use radians for our angles. So this one is nice and easy. Arc length is equal to theta times r. So I know that 22 is 5 theta. So theta is 22 over 5. My inner angle I'll call theta prime. So theta prime is going to be a whole circle minus 22 over 5. And now this area of the sector is 1/2 times theta, and in this case it's my theta prime, times r squared because it's area. All right, and now I can simplify a bit. So that's going to make pi times 5 squared, so 25 pi. That's going to give me 11. One of the 5's is going to cancel, so minus 55. My units here will be square centimeters. I'm going to leave this one for you to finish. We have an arc length, and this is a fun one. I'll write it up for you, and I'll post the solutions for you to look at.